On this construction, we are going to be making two more special constructions on triangles with points of concurrency, and you can find the orthocenter and the centroid. We'll start out with the orthocenter. So go ahead and create a triangle. And add the text next to it for Orthocenter. And in parentheses, put 3 altitudes. Remember, the altitudes are the distance from a point to a line. So we're going to be using perpendicular lines with a point not on the line. Ortho is another word for right angle. So, using your special line tools, choose the first option, that's the perpendicular line with a point not on the line. Select your point. Let's start with point A, and we'll select the opposite side, side BC. All right. Now let's do that 2 more times. C and its opposite side. Notice how it's outside the triangle here. I'll explain that in a moment. B and its opposite side. There we go. Ooh, that one's outside too. So let me adjust point A and kind of move it so now you can see that it's in the inside there. Now, the reason why the triangle can have it so that the intersection of these 3 points is on the outside. You find it on obtuse triangles. See, as soon as it gets 90 degrees, it hits it right on the corner, and then you pull it out, make it acute, and now it's on the inside again. Now, once you have moved your concurrent point inside, that way it's easier to see, go ahead and mark the intersection of the 3 lines, and then change the properties of the lines to be, I'm on the point. Change the properties of the lines to be dashed lines. What's going on here? Anyways, I'll leave them solid for now. You can figure it out. Anyways, on next. Go ahead, you can zoom out a little bit, move the graphics view to the side, make another triangle. This one's going to have a few more steps to it. And this one is going to be called the centroid. Centroid. Now, I spelled it wrong. OID. This is the intersection of 3 medians. And you can remember the median construction from before. That's where you connect the end point, or the corner or vertex of a triangle, to the midpoint of the other side. So you're going to want to find the midpoints for the 3 sides. You can use the perpendicular bisector or the midpoint tool. So I'm going to click midpoint, midpoint, midpoint. There's my 3 midpoints. And go ahead and connect the vertex to the opposite midpoint. And those 3 points are concurrent. You can find their intersection. What's really neat about this one is it's also the balancing point for the triangle. If you were to draw a triangle on cardboard, cut it out, find the centroid, you could balance the triangle directly on the centroid. Kind of a neat little trick. Maybe I'll find a video of that for you. But you move it around, you find out this one here also only stays inside. If you think about it, that makes sense. If you're connecting the middles of lines, it's always going to be, the line connecting to it is always going to be directly in between the other two. So there is your centroid. Go ahead and save and submit this construction.